right, we're going to start talking about types of data and the shape of that data. Nothing new than what we've been doing. But we have made a huge assumption. And that huge assumption is that all the data, or that we have been able to do all of these normal model computations and made the assumption that our data is normally distributed. And that is not always the case. In fact, with real-world data, it's frequently not the case. So we have to address how to handle situations when data is not normally distributed. So we know that lots of data could be unimodal, symmetric, all that kind of stuff, and follow. But does it actually follow the function of the normal model? And that's what happened here. We have this data, but it's not actually following this function. We also have bimodal shapes. We've got that type of situation where here's an example of those people who didn't study for the test and those people who did study for the test. Okay, we've got that going on. You even have got those unimodal distributions, uniform distribution. Here's a distribution of the probabilities of every card. Well, they're all equally likely in a particular suit. So they're all equally likely. So therefore, you have this situation where it is a uniform probability. All right. So how can we do normal model math if we don't have a normal model shape? That's what we're going to talk about in this chapter. So in order to do that, when we do not know what the population shape is to create a sampling distribution. And so that's where we're headed with this. As we talk about this, today is just data collection, but as we do it, I want you to be mindful of population data. That's the set of all of the situations, like all of the shoe sizes in all of the students of Aledo ISD, versus just taking a sample. Maybe we're going to take a stratified sample. We're going to take some from each of the schools and then collect data on those samples. The idea of keeping population versus sample is so important that there are even different ways to notate or write out those specific letters that represent population and samples. So as we go through this, I'll be pointing those out. We will eventually memorize those notations and be tested on those because it's critical to understand what those represent. All right, you picked this paper up when you came in. And what we are going to do is collect data on two types of things, a sample proportion and a sample mean. So you're going to do two data collections today. The first one is a sample proportion. We are going to get 50 M&Ms. That will be your sample size, 50 M&Ms, and you are going to be determining the proportion of blue M&Ms in your sample of 50. Now, before you start diving into that, let's talk about how to properly get this sample of 50. You will be given a small cup of regular M&Ms, but it's probably going to have more than 50. Therefore, without looking, count out your 50 M&Ms onto a paper towel. It is important that you do not look as you do this so that your M&Ms are randomly selected and do not have a bias of a particular color. For example, if you know that I'm going to be counting the proportion or finding the proportion of blue M&Ms, then you may subconsciously be picking out more of the blue M&Ms without even knowing it. So, without looking, count your 50 M&Ms. Once you count your 50 M&Ms, then you can count the proportion that are blue. When you get that sample proportion, your proportion is called your p-hat. So let's look at that notation. The population of all M&Ms that come from a factory that are blue is represented by this capital letter rho, which looks like a capital italicized P. That is the population proportion of all the M&Ms that are blue that the factory makes. But you are getting a sample proportion of your M&Ms, proportion of M&Ms out of 50 that are blue, and that is a P hat. So every single person gets their own P hat. You will then be taking your P hat sticker that you will be getting from the substitute or from the teacher, and then putting it very carefully on the chart. Make sure that you put it in the correct place. So I'm going to demonstrate that now. Suppose that my P hat was 20. Just FYI, since you are doing out of 50 items, you can quickly compute your proportion. If I had 10 blue M&Ms, then, my 50, whatever, I just double it because that 50 doubles to 100. So in that case, I would know that my P hat is 20%. So here's what that would look like on the proportion chart. I'm going to take my little P hat sticker. It's not blue, but it's red, so deal with it. And I'm going to put that over here on the proportion chart. And I need to make sure that I put it on there correctly. So let's take a look at this. There is a block, and each sticker fits properly in that block. So what happens is, and then you'll stack, of course, on top so that we have things that are properly spaced so that they are to scale, and it's a true histogram where we've got that stacking up. Now, looking at the bottom of this, you can see right here is a line where 20% is. Right here is a 20% line. So the question is, where do I put my little thing if the line is 20%? So my little sticker, remember when we did data earlier in this year, the 20% is in from here up to the next tick mark, which is 22%. So from here, so you would put your 20% to the right of where it is located on here. All right, another example. If yours was, say, 30% blue, then I would be coming over here. Here's my 30% line. And I'm going to then take this and put this right there in that spot to the right of that mark. Okay, that's how you do your proportion stickers on this proportion distribution that we're going to build. All right, next activity. The next activity that we're going to do is going to be handling sample means. So we have quantitative data. So here's what we're going to be doing for our sample means. You are going to use the timer on your phone. And you're going to turn to that, and you are going to attempt to stop that timer exactly at the 5-second mark. That's your goal. Mark it at exactly 5 seconds. Do you think that you're going to be getting exactly 5 seconds every time? I don't think so. So you're going to be off from that. So on the back of this page, you will see a table. And that table is there for you to have your trial number. And then you can put the notation of what your time was. I looked at my stopwatch on my iPhone, and it's in this format here. So you'll end up something like with your seconds and your milliseconds. And the next one might be this right here. Okay? And so you'll go ahead and you'll be calculating all of these numbers. And once you get done with all of these 30 times, all of these individual 30 times, you then average them. All right, so taking a look at that. What I would like for you to do is after you get your 30 times, put your 30 times into your list 1 on your calculator, because I want to do more than just get the average. I want to also look at your standard deviation. There's some interesting things we can get from that. But let's talk about the calculator situation real quick. So pull out your calculators if you don't already have those out. And let's recall that we have just come from a chapter where we have done the probability distributions. We did one variable statistics of list 1, but we had list 2's frequency. So the issue with that is when you pull up your calculator and you go stat over to calc and you do one variable stats, do you see if you had a menu here, then you had L1, and look at what you have next, L2. Well, you're not going to have anything in L2. L2 should be blank. You are just finding the data for list 1. So you need to come on down here and you need to delete that out. So it is gone. It is not there anymore because you do not have anything in L2. You do not have your frequencies in L2. You're only computing information for list 1. Now, this calculator I don't think has anything in there, and so that's why it's giving me an error. Now, let's recall, if you're on one of the other operating systems that does not have the menu, then we used to go like this last chapter, L1 with L2's frequency. But again, we do not need to do that because we are not going to have the frequencies in L2. And so what happens is, if your calculator is got the older operating system and you have to do the common thing, this right here is all you need. Just putting one variable stats will then allow you to, it defaults to computing the statistics for the data in list 1. So just putting that is all you will need. All right. When you are finished, you will get your sample mean and your sample standard deviation. All right, so let's take a look at that notation, because remember, that's one of our other goals, is to talk about the difference between that population. So if we were averaging all of Aledo ISD students' time to to get on the 5 seconds, then that would be a Greek letter mu, and all of the population would have a standard deviation of sigma. But you are just taking a sample of 30 times. Since your sample is only 30 times, you don't have a mu, you have an x bar. X bar is the mean of x, but this is the mean for a sample. And you will have a sample standard deviation, your S of x. And that's what will show up then on your calculator. So that's what you're going to use. Notice these Latin letters here are for sample. These Greek letters here are for the population. So this, while we won't use this, we won't be graphing this standard deviation, it's very interesting. This standard deviation you get would be fun to compare to your neighbor or your peers, because that's going to tell you how consistent you were in getting your time close to the 5 second mark. If you have a huge standard deviation, then of course you were all over the place. And I'm sure that's where I would have been. I have my data somewhere, but I'm sure I was way all over the place and not consistent with that. So, in summary, you're going to then go get your X bar. Let's say I averaged my 30 times and I got 5.07563. Because that average is going to be more than just those 2 decimal places. And I don't know what my standard deviation is, whatever, we're not graphing that. Let's take a look at how to then put this number on the mean chart. All right, so you're going to get a sticker that is the green X bars. That's your average of your 30 times. So you will then come on over here And you will see, I think I said my time was the 5.0763 or something like that. But I would like for you to be very careful and round correctly. Will you please? Round to 2 decimal places and round correctly. So if I had 5.0763, of course I got 0.07. This 6 is going to make this round up to 5.08. So that affects where I'm going to put my data. I'm going to then put my data here on the other side of, to the right of 5.8. So see how this is the 5.08. Beside it is the 5.06. So if I had had a number 5.072, then this 2 would have caused this 7 to stay a 7, and then my data, being 5.07, would drop into this space to the right of 5.06, not past the 5.08. All right. So I'm very interested to see at the end of the day, after we have all the data, what the shapes of our sampling distribution for proportions and sampling distributions for means is going to be. I want to see what their shape's going to be. I'm interested to see where they are centered around. And tomorrow we're going to talk about if we had any outliers and what their spread was. So, let's see. We're going to be talking about what is their shape? Are there any outliers? Where are they centered around? And how spread out is the data? We are going to be describing the distributions with our socks. So look for that tomorrow. I am particularly interested in the proportion distributions because over the past 5 years, there have been an introduction of additional factories that put out the M&Ms. Whenever we had data in the Hackettstown, New Jersey plant, when we had M&Ms that came from there was a different proportion of blue M&Ms. If it came from the Hackettstown, New Jersey plant, there was 24% blue M&Ms coming out of that factory. But one year our data was all off. And I was like, what the heck is going on here? Why is our data not centered around this 24%? It came from Cleveland, Tennessee. And so I called up the M&M's company and found that factory has got different proportion of blue, and it's closer to 20%. So I'm going to tell you, looking at the labels of your M&Ms that I picked out for you today, there's not a label for the Hackettstown, New Jersey or the Cleveland one. So I'm very interested to see where do your proportion of blue M&Ms center around, and what can we tell about that? All right, so your goal, get your proportion sample done, get your mean sample done, and get those graphed.